All right, this series of videos is going to be looking at the PTSD EMT data. I'm going through how to prep that data to run it in a multiple regression. We'll deal with issues of missing data, normality, linearity, homoscedasticity of residuals, outliers, multiclinearity and singularity, and outliers in the solution once we actually run the regression analysis. All right, the first step we're going to take is actually run the multiple regression. We're going to look at the regression analysis printout itself. All we're going to do is pop down to that residuals box at the end. In order to start this, we're going to go to Analyze, Regression, Linear. What we're trying to predict are PCLC scores, which is a PTSD variable. We're going to use the Traumatic Event Scale, Social Support, MSPSS total, as well as a variable related to negative cognitions. Now the only thing we need right now is to come in here and get our residuals on the Y versus our predicted values. And these are the Z's of the residuals and predicted values. That's all we need for now. We'll hit continue and OK. We are going to ignore the rest of this data. We're just going to pop straight to that residuals plot at the end. That is not evenly distributed. One of these residual plots, we actually want it to be at this line of 0. We want that all of the residual dots to basically be scattered and centered around the line of 0 and evenly dispersed across. We have a big missing pocket down here, then we have a clumping of data right here, and then sort of shotgun spatter from there. So that's not looking too pretty. We're going to need to go and check our variables a little more closely. And in order to check our variables, let's go to Analyze, Descriptives, Explore. We're going to pop all 4 of our variables, including our dependent variable and our independent variables, into that dependent variable list. And at this point, we want to go under Plots, and I don't particularly care for a stem and leaf. I'd rather have a histogram. And we also want some normality plots with tests. We can also go under Options, and here we could choose listwise or pairwise. Since what's actually going to appear in the regression is listwise, I would leave it at that for now. Let's go ahead and click on OK. The first thing we notice is that we only have data, complete data on these 4 variables on 71.4% of our cases. We can see that here in that valid percent. 28.6% of them are missing data on 1 or more of these variables. That's not excellent, but our N is still high enough for the regression that we're running. We might want to go back and look at each one of those variables to see if one of them is contributing a lot to the missing data. The other thing we're going to want to do is go down through the descriptives for each one of these variables and look to see if our data are skewed or having any other issues. We can see that the PCLC has a fair amount of positive skewness, looking at its statistic in relation to its standard error. Similar for the TES. The NCW looks well distributed. I'll want to check out its histogram, but at least from its statistics numbers, it's looking okay. And the MSPSS is looking extremely negatively skewed. And if we look at the tests for significance, we'll go with a 0.001 on these. So the NCW is within normal limits, but the PCLC, the TES, and the MSPSS look like they're going to need to be transformed. And let's just finish up by taking a look at those histograms. Here's the PCLC, and that definitely shows a positive skewness. The TES histogram, also showing some positive skewness, but not too bad. The NCW, which was the one that did not surpass, that looked within normal limits. And that data, it's a little bit platykurtic and a little bit skewed, but not bad. And finally, the MSPSS, which is highly negatively skewed. Next video, we'll look at how to fix those.